All right, so we will go ahead and get started with our webinar series for this month. We really appreciate you joining us for the webinar, especially after a long holiday weekend. This month we were going to take a deeper dive into Azo Organic Pigments, and we are recording this webinar. And so that you are able to receive the recording link as well as the PDF of the presentation after after the webinar. If you have any questions, feel free to use the chat box, and I'll address them at the end of the presentation. If that is not your thing, that's okay. Just shoot me over an email and I'll answer your questions. So with that, I will go ahead and get started with the webinar. I'm just going to go off camera here and we'll take it from there. All right, so we are okay, so a couple of fun facts with respect to Azo pigments. Sudarshan has 72 out of a total of 230 color indexes in the Azo chemistry, 31%. It's quite a large number of available color indexes in the overall Azo chemistry. And of those, there are more than 362 commercial products that cover that space of 72 color indexes. And these products are both in the powder form as well as in the liquid colorant form. Another fun fact is that the first commercial Azo pigment is Pigment Yellow 1. It was developed and commercialized in 1913. So the Azo class of pigments are by far the largest in all of the organic spaces. They are in two categories, the monoazo and the disazo. And they also span both high performance pigments as well as the classical pigments. And those are the definitions with respect to some of the technical performance properties. So azo pigments, why do we use them? They are applicable for all types of applications where color is needed. Coatings as plastics, inks, special applications, all types of applications are appropriate for azo pigments in one form or another. As I mentioned, that this is the largest volume of organic pigment types, and these are manufactured in all of the continents of the globe. From a color space coverage perspective, for the most part, there is something available in all of the color spaces that you may need. These are environmentally stable, and they tend to be very cost effective for your formulation. From a color space, I mentioned they span quite a wide space. So on the yellow side, both in yellow three being very green, all the way through to pigment yellow 181 being very red shade in the yellow space. Orange space as well spans the yellow shade through the red shade. And then in the red space, from the yellow shade to the blue shade, and you can see quite a number of color index numbers that are in the red space. So I mentioned they both cover both the classical pigments as well as the high performance pigments. And as the name implies, they are classified that way in terms of their performance perspective. The classical tend to be lower to middle fastest properties, and lower to middle heat resistance as well. So but they are also have a lower cost to the formulation. The flip side, of course, is the high performance. These were developed to be able to move those color spaces to a higher performing area so that your fastness properties are higher. Your heat resistance is higher. So there are more opportunities for exterior usage as well as higher processing temperature usage. There are a lot of subcategories within the azo type of chemistries. This slide here just gives you a number of individual subcategories with respect to azo chemistries. So there are a number of them, as you can tell. All of the highlighted uh, color indexes here in the slide are those chemistries that Sudarshan does have in the portfolio. The ones that I've highlighted in blue are ones that I have more information in this presentation for. So was hard for me to keep it a little bit more narrow and focused. So I might just go ahead and put together a part 2 for this so that I can highlight some additional color indexes for your information. So we've always talked about the synthesis and that the chemistry dictates about 75% of the performance of that one. This is no different with respect to the azo chemistry. This is even more important because the azo chemistry breadth of products and color indexes are so broad. As I mentioned, high performance classical, so there's a lot of options for technical properties to be had within the azo family of chemistries. And then the remaining is in the finishing choices that are made for that particular product. In a lot of color indexes, as you'll see in upcoming slides, there are many pigment product options. And it's those choices that are made in the finishing steps that create those individual products, and then those individual technical properties that you'll receive at the end. So we'll take a look at each of these categories in a little bit more detailed, and then following this generalized types of slides, I have a little bit more information on about a number of the individual color indexes and some product information to go along with that to give you a better feel for what's available, what they can do for you in your formulation needs. So the most basic is the monoazos. These are chemistries that have a single nitrogen double bond that signifies the azo chemistry. Some typical color indexes are the yellow 1, as I mentioned, yellow 3, 65, and 74. These tend to be mostly in the yellow shade area. There are some in the orange space as well. Yellow 74 is by far the largest in this class of azo pigments, and is used in a lot of different application areas and sub-application areas. As a category of pigments, the monoazos tend to have lower to mid durability. They're also mostly opaque. However, there are a number of um, uh, semi-opaque or even transparent ones available in certain color indexes. They do tend to have lower solvent resistance and lower strength. However, they do offer a more economical pricing point for your formulations, but need to manage the pigment chemistry with your application needs. So one of the things that I like to offer is how do we get from one color index to another? And in the mono azo family, I consider the pigment yellow 1 as the base pigment structure. And you can see that molecular structure to the right-hand side and its color positioning. Now, as you move through and change that those side add-ons to the nitrogen double bond spacing of the azo, you can start to see how the chemistry results in a different color space as well as properties. So we move from the base of a pigment yellow 1 through through the yellow 3, yellow 74, and yellow 65, going from very green shade to very red shade, just by changing some of the items on that base structure. From a product perspective, there's a number of things on this on these types of slides that I would like to bring your attention to. First, I will go through a little bit about the uniqueness of that particular pigment chemistry. So pigment 1, of course, is a strong opaque, the mono azo pigment. As I mentioned, it's the very first one that was commercialized in here, so very green shade and opaque. The other things that I wanted to do is, as we did in our last webinar, is I give you an idea of the products availability and what type of form they come into. So whether the liquid form or the powder form. In this webinar, I also wanted to give you a feel for, on the liquid side, some of the brands that are available and what those brands are intended for, so that you can get a better idea of how they might be appropriate for your application needs. So in this case, I've highlighted when they become unique, I've highlighted them in and as well as bolded them in terms of the product line, and then gives you a feel of how what area these are appropriate for. So for example, the Agrosur line, both in liquid form as well as the powder form, these are intended for agriculture type applications. Collodial, well-known liquid colorant. These are APO-free water-based colorants. And then the Cosmonel are also a liquid colorant that is intended for the personal care space. So you'll see these types of things appear throughout the presentation when they show up as a unique item. Yellow 3, continuing down the mono azo line of pigments, is a very popular pigment for for decorative types of coatings area. It's still very green shade and is particularly suitable with combinations with green 7 to keep that green shade but to the yellow side and keep that nice green color in there. The Hasatit line is a liquid colorant that is also APO free. It's also binder free, intended for water-based coloration. Yeah, pigment yellow 74. As I mentioned in the introduction slide here for mono azos, this class of color index is by far quite large, as you can see with the number of products and the form of the products that Sudarshan has to offer. Pigment yellow 74 is sort of more of a mid shade type yellow. It also has the uniqueness in that there are products that are available that are recrystallization stable, so that there are some forms of, or from some formulations where this might be an issue with respect to stability in terms of strength. So there are options there to be able to have that. From a liquid perspective, we start to see the Aqueous brand of colorants. These are water-based point of service and implant tinters in there. We're using the Pigment Yellow 74 colorant. Heucosperse is also a water-based, based off of styrene and acrylic for ink application areas. The Heuco tint is also a water-based point of service colorant. Microsperse. This is also a styrene acrylic water-based colorant, but these are more transparent for ink applications. And then lastly, the Viscofill. These are based off of anionic dispersants, primarily for the coloration of latex. Pigment Yellow 74 is a well-used pigment or color index in coatings, as well as ink. So you can see some toner applications, there's inkjet applications, as well as the standard, more traditional ink and coating application areas. And then last in the line of monoazos is the Pigment Yellow 65. So here, think traffic paint. This is one of the key things. So the yellow lines on the street primarily is Pigment Yellow 65. This is a very red shade pigment in the monoazo category, as often used for traffic paint as well as also in architectural coatings. Moving next to the metal azo yellows. The two primary color indexes in this category is the Pigment Yellow 62 and the Pigment Yellow 91. These two chemistries are what I'll call sort of workhorses in plastics. They're very much well used in these areas. This is generated by creating a salt complex with the azo, and these are two of the major options in here. Pigment Yellow 191 is also a good option for powder coatings as well. These two pigments in the chemistries in this category also offer both a lower performance with the yellow 62, primarily because of the heat stability is lower. Whereas you have the Pigment Yellow 191 being that higher performance based off of the heat stability. So typical properties of these are, they are, as I mentioned, very a difference in terms of their heat stability. So processing temperature and polymer choice have to be considered when selecting either one of these pigments. They are relatively low in cost, and the Pigment Yellow 191 does bring with it an FDA compliancy, so that's always a helpful thing. Pigment Yellow 162, of course, is also a green shade in there. It's very cost effective with excellent dispersibility. And a lot of times it can be substituted for diarylides as well when there is some potential heat issues with that one. These two products come from the Legacy Sudarshan side. And as I did last month, I also are providing some color design options using some of these pigments. So this tangy orange color is a simple formulation of the yellow 62 along with a red 53 and a gold pigment. Pigment yellow 191 is more mid-shade yellow, but it does bring with it that high heat stability, and is a very good replacement for diarylides when you do need that higher heat stability. A number of powder pigments options are available to fit your needs, and processing needs as well. Diarylides, so these are this azo, so they're going to have two of those azo nitrogen double bonds in the structure. This is a very large category of azo pigments. In the yellow space, some very important ones are yellow 12, 13, 14, 17, and 83. Orange space, a very important one is the orange 34, and there are some in the red space as well. So it does cover a number of color spaces with some important area. Primarily, the diarylides are used in printing ink because they do bring with it high color strength. So they do have a very good value in use to bring to the properties. However, you need to be able to match the performance with your formulation and processing arrangements as well. Diarylides are not FDA compliant, so that should be something to take into consideration in your formulation and your attribute list. And then, of course, their lower heat stability limits. So they are much more limited in plastics areas. Some of the typical properties that come along with diarylides is their strength. So over the monoazos, the diarylides are much more stronger. They typically tend to be more on the transparent side. Um, so, but given the extra strength there, the more transparency, we tend to have lower heat stability and lower durability as well. To start off, similarly, I use the Pigment Yellow 12 as sort of the base structure within the diarylides. And then if you move through yellow 13, 14, 17, and 83, and you can see on the right-hand side how those structures are altered to get those different chemistries from that base structure. They also move through from green shade to very red shade with the Pigment Yellow 83 as well. So for the Pigment Yellow 13, so Pigment Yellow 13 and 14 are the two workhorses primarily on the ink sides, and these tend to be kind of regional, not specific, but there typically is a more of a desire for one color index over another color index, depending on what part of the world that you're in. Um, the yellow 13 is a very economical because it does bring with it high strength. Again, that processing temperature shouldn't go above 200 degrees C for that one. Some new liquid colorant brands are come in with the Pigment Yellow 13. So Hostafine. These are made with non-ionic dispersants, and they are typically are transparent for wood stain application areas. The Lycosperse is a liquid dispersion based off of mineral oil for the coloration of oils and waxes. And then lastly, Hostacin is a finely dispersed a preparation for the coloration of rubber and other elastomer type of products. So a number of different products are available in this. We do see some application in plastics. However, again, that processing temperature needs to be considered as you select a pigment. As I mentioned, the Pigment Yellow 14 is the other sort of workhorse for the process color of yellow in inks. This is a green shade. Pigment Yellow 14 tends to be more green than the Yellow 13, and it does offer that higher strength as well, which is known for the diarrhylides. So a number of products available as well. And then continuing down the line of diarrhylides is the yellow 17. This is starting to move a little bit more towards the mid shade range. Yellow 17 tends to be very transparent and provides high strength and gloss to ink formulations. Pigment Yellow 83. So like the Pigment Yellow 74 in the mono-azo category, the Pigment Yellow 83 in the diarrhylide category is an obvious workhorse in terms of the number of products available, its usage in all application areas. So Yellow 83 is a strong but very red shade diarrhylide pigment. This one does provide better light fastness properties as well as overall fastness. We can get both opaque and transparent grades available. So this is in a similar space to the yellow 65 that I mentioned in traffic paints. The yellow 83 fills that same color space, but with improved properties so that it can potentially offer some additional attributes to your formulation if that's required. A couple of new brands show up with the Pigment Yellow 83 here. The Flexo Print is a surface treated pigment for aqueous printing inks. And then there is the Hostanol line, which are non-dusting pigment preparations in a granular form that can also be used for wood staining applications. So a number of different choices and products available. So it's always good to work with a manufacturer like Sudarshan to be able to help match your application needs with the correct product. Next, going down the line is a very small category with the Pigment Yellow 155 being the dominant pigment color index in that particular category. These are also typically high in strength and good resistance to solvents and other acid and alkali resistance. Good light fastness and weather fastness. Very often used in inks and plastics as well. The Pigment Yellow 155 is more of a mid shade, but to the green side. But it does bring overall good fastness properties to your formulation. The Hosta Jet line of liquid colorants shows up with a Pigment Yellow 155. These are an aqueous pigment dispersion based on polymeric dispersions, primarily for inkjet types of formulations. So a number of options with respect for coatings and inks and plastics as well. Pigment Orange 34 is another area in the overall diarrhylide type of azo chemistry. In in the molecule here that I show, identify the disazo. You see that with the two nitrogen double bonds, and then the parazolone uh, additive on the ends there to make that pigment orange 34. These are important because they are key orange color pigments in this particular form. They tend to have high strength as well as either opaque or transparent. So, and they also show up a lot primarily in ink application areas. So Orange 34 is one of the key ones in this grouping. It is a very red shade pigment, opaque and transparent. Grays are available. The one nice thing about this one is it tends to have very good flow properties with higher pigment loading in the formulations without affecting gloss in a coatings formulation. But it also has to be very careful with this particular one in terms of keeping that cure or process temperatures below that 200 degrees C. The naphthols, the beta naphthol and naphthol AS type of pigments, these tend to be the orange and red spaces. A number of pigments fall into this category that are again, I'll use that phrase, the workhorses of a lot of different application areas. The naphthol key one here is pigment red 3, the AS. We see the red 2, 22, pigment red 112, 170. These also span both the classical type properties as well as some higher performance type properties. So a lot of options in this particular chemistry category. Some key ones here, the pigment red 3 tends to be either opaque and yellow shade or a semi-opaque and a blue shade. So options there. They do have good performance in terms of fastness, especially when you're trying to get to some darker shades. They can be used for both solvent and water-based coatings application areas. And is one of the keyer ones that shows up in some of the special application areas, things like stationery or artist colors. So a lot of uses for Pigment Red 3. Pigment Red 2 is one of the key ones in inks. They is to the mid shade from a color space perspective, although they can be shifted either more blue or more yellow, depending on what you need. This chemistry is a great option if you're trying to avoid formulating with barium-containing pigments when you're trying to get a clean red shade. So this is a good option for that. From a coatings perspective and inks perspective, this is also very suitable for both solvent and water-based formulations. Pigment Red 170 is a very useful tool in your color formulating toolbox, definitely in coatings and also in plastics. Not as popular in the inks area, except if you need a higher temperature clean red aspect of it for such applications like a metal decorative where you need a higher temperature, processing temperature or cure temperature. The Red 170 also offers yellow shade and blue shade versions so that you can get to where you need to be. This type of chemistry does have great light fastness and weather fastness, especially with respect to TiO2 in the very pale pastel type shades. in here. It has a a better response than the Pigment Red 254 in those very light pastel shades. From a product perspective, there are a number of areas here, products available for that aspect of it. I added a couple of color designs that I've done over the years here, both in a coatings formulation as well as a plastics formulations, and both cases, even though this is a more towards an opaque type pigment, the use of some mica does show up in these formulations, so that makes some very attractive colors with Pigment Red 170. The B naphthol lakes. This takes the regular naphthol and then complexes it with a salt on there. Those salts can be either calcium, barium, or strontium. They tend to range more towards the bluer side in terms of color space. These types of chemistries do have better migration and solvent resistance. However, that you'll give up a little bit more on the light fastness versus the regular beta naphthol pigment classes. A good example in this space is the Pigment Red 53-1. This is more of a yellow shade red, a very cost-effective pigment, but it does have very good dispersibility. There are lower barium grades available, so there are some options there. Going back to this tangy orange color development, this is a combination with the Pigment Yellow 62 to be able to get that lovely orange color with the gold mica in that plastic formulation. Metal azo reds. This is a big class of pigments in primarily in inks and in plastics. These tend to be spread the color space from red, yellow shade red to blue shade red. They tend to have very clean red and good solvent resistance. Durability certainly not as high as some of the high performance pigments, but they are more economical. And then they also fall into that classical area from a heat stability perspective. Pigment yellow or Pigment Red 57-1 is one of the bigger volumes in this class of pigments. Other ones that are important in the area are the Pigment Red 48-1, 2, 3. Excuse me. The one thing that I always like to take a look at is these the monoazo salts and how they are very, very similar in their chemistries. It's just that salt difference that make a difference in terms of the color space as well as some of the performance properties in here. So here is an example of the Pigment Red 48 series, if you will, where the 48-1 uses a barium in this space here. 48-2 uses the calcium. 48-3 uses strontium, and 48-4 uses the manganese. The base structure is identical, just the salt changes, and then that results in the ultimate of the color space difference. And this is always interesting when you take a look at the periodic table. And yes, I did bring in a periodic table. So all those geeks out there can take a look at here. So if we fall down the second row from calcium to strontium to barium, we see how the color positioning changes from blue shade to yellow shade. And then also the strength difference that also shows up there as well. Now, if we go across the row, which is row 4, from calcium to manganese, we see that the color shade moves from um, a what is a really a blue shade to an even bluer shade, and we definitely see that in the tint tone formulation. So these salt differences definitely make up the the uh, the color space, and then of course there also is some physical property differences between the two. 48.2 is, as I mentioned in the previous slide, is the calcium lake grade of that space. You can find both a more yellow shade and a more blue shade in this color index. It's especially a useful tool in the plastic area for single pigment concentrates in terms of master batches. It does offer high strength and good fastness properties. Pigment Red 48.3 is the strontium version of this lake pigment. It is a little bit more to the bluer side. And again, we see a couple of color designs utilizing the Pigment Red 48.3 in a decorative coatings formulation, as well as a plastic formulation to get this purple shades. And then Pigment Red 57.1 is again one of those color indexes where there's a lot of products available to meet all of the needs that are out there in the different application areas. It's also a calcium lake pigment, so it does have that calcium on there. It can be found both yellow shade and blue shade, as well as a variety of transparencies, depending on what your application ultimately needs. Benzimidazoles. Here we're transitioning to some more of the high performance pigments. These tend to be workhorse pigments in both coatings and plastics areas. Some key ones in the spaces from the yellow side is the Pigment Yellow 151 and 154. On the orange side, it is the orange 36 and 64. And on the red side, the 176 and 185. These, as I mentioned, do have the high performance nomenclature associated with them. So that gives them higher durability, higher heat stability performances with respect to those application areas. So yellow 51 is a very green shade yellow, very light, fast, and durable for coatings, and we also see it in inks, but it also does show up with plastics as well, because it does have higher, it's nice and opaque, nice and green shade with that higher heat stability as well. One thing to consider with respect to Pigment Yellow 151 is in certain application areas, it can be impacted by a strong alkali. So that has to be considered when doing your formulation and the end application area as well. Pigment Yellow 154, now we're moving a little bit more red in the yellow color space. This is primarily a coatings type of chemistry, and is a little bit more red than the 151. It does bring with it, very, very good weather fastness properties. The one positive thing with it, it's not sensitive to TiO2. However, the one negative, if there is that its strength is lower than other lower organic pigments. But it says definitely have to balance the properties with what you are looking for with respect to an attribute list. Next up is the Pigment Yellow 180. And this is something that we're now starting to move a little bit more red in the yellow space. So more of a medium shade yellow. This is a very good high heat stable pigment. Very useful in plastics. It also provides, doesn't impact shrinkage with respect to plastics. It also does very useful for powder because of that higher heat stability. Also, in some of the higher processing temperatures for inks, like metal deco, where the diarylides would decompose at above 200 degrees C. So some options there. Again, selecting your pigment chemistry to meet your application needs. Orange 64 is definitely the workhorse orange for plastics. A very yellow shade, very opaque, and very high heat stable pigment. And it does have a lot of options, a lot of uses in plastics. It can be useful for inks and powder coating because of the higher heat stability area. The one thing to consider though, it does have a lower weather fastness properties, especially when TiO2 is involved in there. So something to consider, but there are ways to get around it, that particular issue. Orange 36 is the workhorse orange on the coating side. This is a very red shade pigment with great weather fastness. It is like the Orange 64, sensitive to the TiO2. So we typically recommend using a CICP like a Pigment Yellow 53 to get that opacity, get the heat stability, get the weather stability, without getting away from the color space you're looking for. And with Orange 36, it's a softer pigment, so I always give a little cautionary comment about not over grinding this particular pigment in coatings formulations. Otherwise, you're going to push it over to a duller, darker color. And here is um, a uh, a coatings application. This one actually happens to be a base coat tinted clear coat with the orange 36 and yellow 53 as the base coat, followed by a mica tinted clear coat over top of it. Pigment in the red side, Pigment Red 185 is more of a blue shade pigment, to be able to provide that nice blue shade pigment in this space. Still high strength, high heat stability, and good fastness. Brown 25. This is a very, very lovely shade for coatings and plastics. It's a nice brown shade to be able to have in your color toolbox. It doesn't cause warpage, so very good for injection molding type applications in plastics. And the nice thing about it, it has a very good transparency, which makes it an excellent choice when you're using effect pigments like micas. The azo condensation area, this is the other area in the high performance space of pigments. Not as many pigments in this particular family, primarily because this type of manufacturing has fallen in terms of um, its popularity in terms of manufacturing spaces. Key ones here, though, are Pigment Yellow 155, Yellow 93 on the red side, Yellow 166 or and 242 in there. These do have the high strength area, good heat stability. Red 166 is a little bit to the bluer side in terms of red color space, good heat stability. It does have some warping issues, so need to consider that when considering it for a plastics formulation. It's also a very useful tool in ink formulations. Red 242 is a scarlet color in the red space. Excellent fastest properties. Again, it does have some warping issues, so consider that when looking at it for a potential plastic application. It also shows up in both inks and coatings formulations. Metal complexes is this example here is a pigment yellow 150. Again, you see it's a monoazo with a single nitrogen-nitrogen double bond, but bringing in that metal, in this case, it's a nickel that comes into that structure. So Pigment Yellow 150 is towards the green shade side of the yellow space with great fastness properties. It shows up in both ink and coatings and plastics. So overall, selecting a pigment is can be a daunting task. However, if you have a good attribute list, you can select the pigment that is valuable ultimately to your end customer because now it performs in the correct manner. It gives you the correct color that you're looking for, and it also matches all the application aspects that it's needed for. And each of these markets are unique. They're all going to have different needs from a technical perspective as well as the color perspective. So making that choice is very important. And as you saw in some of the slides that I presented today, in each of the color indexes, there are many options to consider based off of the formulation, the chemistry formulation, and then from there, the finishing choices that are used. So there's always going to be more than one option in a lot of cases. So it's my job really to make sure that I match up the right product for your needs in terms of formulation and color. So this is a slide you see every single time, but it's always a good reminder that it's always going to be a balance of balancing the performance from the pigment side as well as and balancing that and matching it to your application needs in there. So consider the chemistry of the pigment, the finishing choices of the pigment, as well as the chemistry of your application and the processing of that application to be able to get the end product that you're looking for. And as long as you have a good list of attributes that you're identifying the things that you have to have, your wants and your nice to haves, that's always an important place to start. And using the pigment suppliers and manufacturers is a very good tool to have in your back pocket when you're selecting a pigment because as you've seen in these webinars, we do have a good knowledge of the properties of the pigments, what they can and can't do. But more importantly, we can offer options to optimize the formulation to get around a property that you don't like, those types of examples to be able to get you where you need to go. So that ends this particular one. Sorry, it was a little longer than planned, but there was a lot of information in here. Next month, we'll dive into inorganic pigments and take a look at CICPs. That'll be the last Tuesday of the month in June. And we will continue down the series. I'm still working on what to bring you in July. So with that, I would like to open it up to any questions that you might have.